Hey Leo, it's Christian. This is an interesting problem, and the thing that we're doing is you fired that ball, and the ball goes into a box, and then both of them travel up. So in order to find the speed of the ball, what we're going to do is we've got to find out how much potential energy the ball and the box have at the very top. So right here, it's going to have gravitational potential energy, and that's mgh, but that's for the box plus the ball. How do we find out the height is the big question. So I know the length of this thing is from here to here, and so when it swings, well actually when it swings down, so the length is actually from here all the way down to this little guy here. So to find out how high it goes, what we're going to do is we also know that this length is the same as the length when it's just going from the top down to the bottom. If we make a triangle, so you'll see this line here, we have this side of the triangle, which is the cosine side, and this is the hypotenuse. We can say that this side is L times the cosine of 35. So if this is H, and that's L cosine of 35, and the whole thing is L, we can say the height is equal to L, which is the whole length of the string, minus this part, L cosine of 35. And that gives you H. So now what we're going to do is come down here, and we've got to find the final speed of both things together. So we're going to say that's 1/2 the mass of both the box and the ball times the speed squared, and that's equal to the mass of the box and the ball times gravity times height. But what's cool is you don't have to worry about the mass of both things, because in conservation of energy it won't matter. When we solve then for the speed of the two things together, you're going to get V is equal to 2 times gravity times the length of the string minus the length of the string times the cosine of 35. But the thing you have to realize is that is the speed of those two objects together, but we want the speed of just the ball. So now you have to go back, and now we have to use momentum. And we know that this collision is the mass of the ball times the speed of the ball original plus the mass of the box times that box's original speed, but it was 0. So we're just going to put a 0 there. And that's equal to the mass of the ball plus the mass, and I'll put an X again for the box, times the final speed. But that final speed is the speed you found here. So you'll plug that speed into the final speed, put in the masses of the two things, the box and the ball. Over on the other side, just have to put in the mass of the ball, and then you can find the original speed of the ball, and that is all you need to do the problem. Hey, thanks for meeting with me tonight, and hopefully this is super helpful. Talk to you later. Bye-bye.